In Module 6, Lesson 6, we're going to describe the center of a distribution using the mean. Recall that in Lesson 3, Robert, a sixth grader at Roosevelt Middle School, investigated the number of hours of sleep sixth graders get on school nights. Today he's to make a short report to the class on his investigation. Here's his report. I took a survey of 29 sixth graders asking them, how many hours of sleep per night do you usually get when you have school the next day? The first thing I had to do was to organize the data. I did this by drawing a dot plot. Part of our lessons last week was to identify what we thought was a centering point of the data, the spread of the data, and the shape of the data. So for my data, looking at the dot plot, I would say that the typical number of hours sixth graders sleep when they have school the next day is around 8 or 9, because that is what most students said, and the values are kind of in the middle. I also noticed that the data were spread out from the center by about 3 or 4 hours in both directions. The shape of the distribution is kind of like a mound. Michelle is Robert's classmate. She liked his report, but has a really different thought about determining the center of the number of hours of sleep. Her idea is to even out the data in order to determine a typical or center value. Suppose that Michelle asks 10 of her classmates for the number of hours they usually sleep when there is school the next day. Suppose they responded in hours the following values. How do you think Robert would organize his data? What do you think Robert would say is the center of these 10 data points? Well, since Robert seems to like the dot plot, Robert would probably use a dot plot. And based on his response before, he will probably think that 8 is the center, since 8 is the number that is repeated the most times. Do you think his value is a good measure to use for the center of Michelle's data set? And respond to that on your own. Michelle's center is called the mean. She finds the total number of hours of sleep for each of the 10 students, and that is 90 hours. Then she has 90 unifix cubes, those are snap cubes. She gives each of the 10 students the number of cubes that equals the number of hours of sleep each had reported. She then asks each of the 10 students to connect their cubes in a stack and put their stacks on a table to compare them. She then has them share their cubes with each other until they all have the same number of cubes in their stacks when they are done sharing. If you were to work in a group, and each group of students gets 90 cubes, you could make 10 stacks of cubes representing the number of hours of sleep for each of the 10 students. Using Michelle's method, how many cubes are in each of the 10 stacks when they are done sharing? Well, if we have 90 cubes altogether, and we're sharing it among 10 students, or 10 stacks, each stack then should have 9. Noting that 1 cube represents 1 hour of sleep, interpret your answer to exercise 3 in terms of number of hours of sleep. What does this number of cubes in each stack represent? And this value is called the mean. Because it is the average or exact middle. Suppose that the student who told Michelle he slept 7 hours changes his data entry to 8 hours. You'll need to get one more cube, and then what does Michelle's procedure now produce for her center of the new set of data? So the new cube changes Michelle's mean to 9.1, and she would have to break apart the cube into 10 pieces in order to share it. Interpret Michelle's fair share procedure by developing a mathematical formula that results in finding the fair share value without actually using cubes. Be sure that you can explain clearly how the fair share procedure and the mathematical formula relate to each other. The fair share procedure is the same as adding all of the values and then dividing by the number of data points. In example 2, suppose that Robert has asked 5 sixth graders how many pets each had. Their responses were 2, 6, 2, 4, and 1. And Robert showed the data with cubes as follows. Note that one student has 1 pet, 2 students have 2 pets each, 1 student has 4 pets, and 1 student has 6 pets. Robert also represented the data set in the following dot plot. Robert wants to illustrate Michelle's fair share method by using dot plots. He drew the following dot plot and said that it represents the result of the student with 6 pets sharing one of her pets with the student who has 1 pet. So what we have then is we no longer have a student with 6 pets. She drops down to 5 pets. And the student who had 1 pet now has 2 pets. Robert also represented the data with cubes, as shown below. So now we have 3 students with 2 pets, 1 with 4, and 1 with 5. If we would then continue distributing the pets, Robert does a fair share step by having the student with 5 pets share one of her pets with one of the students with 2 pets. And so the cube representation will now look like 2, 2, 3, 4, 4. And the dot plot that Robert would then create would look like this. 2 stacks with 2 each, 1 stack with 3, 2 stacks with 4 each. Robert does another fair share step by having one of the students who has 4 pets share 1 pet with one of the students who has 2 pets. So we'll draw the cube representation for that as well. And as we can see, Robert now has 1 student with 2, 3 students with 3, and 1 student with 4 in the cubes. The dot plot for Robert's fair share step then shows 1 student with 2, 3 with 3, and 1 with 4. So Robert will do one final fair share step by having the student who has 4 pets share 1 pet with the student who has 2 pets. And we can see when that happens that he now has 5 students who all have 3 pets each. is dot plot representation then. Looks like this. There are 5 students and each one of them has 3 pets each. In this lesson, you developed a method to define the center of a data distribution. The method was called the fair share method, and the center of a data distribution that is produced is called the mean of the data set. The reason it is called the fair share value is that if all the subjects were to have the same data value, it would be the mean value. Mathematically, the fair share term comes from finding the total of all the data values and dividing the total by the number of data points. The arithmetic operation of division divides a total into equal parts.